Good afternoon. It is 12 o'clock, and if it's 12 on Wednesday, it's time for another Iowa Learning Farms conservation webinar. And so it's my pleasure to be able to moderate again today. I'm Matt Helmers in the Department of Ag and Biosystems Engineering at Iowa State University, the director of the Iowa Nutrient Research Center, and also fortunate to work with the Iowa Learning Farms group. And so the best part of my week is getting to moderate these webinars. And today is especially exciting because we get to hear from Dr. Andrea Basche, that's at University of Nebraska-Lincoln. And she is an alumnus of Iowa State University. And I had the great pleasure to get to interact with her a little bit when she was working here as a graduate student on the Sustainable Corn Project. And then it's been really exciting to see all the great things that she has done. My voice is distorted. Okay. Are other people finding my voice distorted?
Yeah, it's not too bad though, Matt. We can understand you.
Let me check to make sure I'm on the right. That's okay. But we'll try to get through it. Okay, thank you, Rebecca. So Dr. Basche is, as I said, at University of Nebraska-Lincoln. So what I'd like to say is that it was great to know her as a graduate student, but as an alumnus of myself of the University of Nebraska-Lincoln, it's great to see somebody of her stature helping in that state as well. And so with that, as I tried to stumble through an appropriate introduction, I'm going to turn it over to Andrea for her talk.
Thank you, Matt. It's very kind of you to say, and I really appreciate the invitation and opportunity to talk with so many of you right in the middle of your week. And as Matt said, I finished my PhD at Iowa State in 2015, and so anything that I get to do related to Ames is always a fun opportunity. So I have been at the University of Nebraska here in Lincoln in a research and teaching position for just over 4 years now. And I was involved with a lot of cover crop work in Iowa, and I'm also doing a lot of cover crop work here. And that's what I'm going to share with you today. And so I wanted to share some of my, again, current and a little bit of some prior work and make reference to some work we did in Iowa, and just to really get us thinking about the way that we frame our thinking about cover crop management and what we can learn from that in how we manage our cash crops and how we can transfer that to cover crops. And so maybe some of the things I'm going to talk about today are things that you've already been thinking about or doing, but I think that framing is really important as we continue to see interest in cover crops grow day by day, season by season. I think that some of these strategies can be, and framing can be really helpful in us being successful in how we reach the goals that we have for cover crop use. And so in my role, I also teach a few different undergraduate courses. And I wanted to start by sharing something from some of my courses. And so this is a slide that I show in my 200 level crop management course, which is taken by students across the College of Agriculture. Again, introduction to field crop management. We focus on corn, soybean, and wheat in Nebraska. And I show this because I just want to take a step back and get us thinking about how we manage cash crops, the various decisions, management considerations that are related to producing high yielding or highly profitable crops, right? So these are some of the things that we focus on in the class: planting dates, variety selection for particular environments, seeding rates, fertilizer considerations. I have them commit some of these things to memory, or at least just, have some familiarity with them. And, when I talk about cover crops in this context, I'm really thinking about places like Iowa and Nebraska, where we have minus 15 in February, cold weather, right? Where we don't have as many heat units in the winter, where we are, constrained in growing cover crops to the predominant cropping systems of corn and soybean that we have. And so my presentation is really kind of focused on where it can be more complicated to grow a cover crop. And I wanted to start just with a question. You can respond in the chat if you'd like. And so when you're thinking about some of these factors, for cash crops, would you say that you were thinking about your cover crop management in more detail or less detail? than compared to a cash crop. So you can just say more detail or less detail. And we're thinking about how your cover crop management compares to cash crop. So feel free to just respond to that in the chat or just be thinking about it. Okay, I got one response of someone saying less. They're thinking less about some of these factors when they're managing their cover crops. So we got one vote for less. Maybe there's more thoughts.
Andrea, I had one person send to me more.
More. Okay, so we've got one vote for more, one vote for less, one no thought.
No thought.
Okay. Okay, less. Okay, so less, even though I know better. Thank you for that comment, Brian. Okay, so some people are saying more saying less, some no thoughts. And, I start with this framing and the way we talk about things in my class because, we know variety selection is important. We know how much time people spend picking out, corn or soybean variety that they believe are best suited to their conditions. And, when you think about selecting, cereal rye, common cover crop, how many people would select a variety not stated seed for corn or soybean, right? And when we think about, planting and timing and all these things, we know that we're spending considerable time and effort, especially on those first two factors that I mentioned. It's really what I want to focus on today. And what we've done in some work, and I put it in the chat before I started, we've done some modeling and some estimates of trying to consider cover crops following corn, some different planting timing, some different maturity length corn, and how that can create an opportunity to plant earlier for your cover crops, right? And so I show this again here as, planting date, variety selection are two really critical considerations for our cash crops when it comes to high yield. And so when we think about planting dates and variety selection, what are we really talking about in terms of resources? And the name of my course is actually called Resource Efficient Crop Management. And I joke sometimes that we could have a lot of discussion around what that actually means. It could mean a lot of different things. So what are we really talking about when we are saying we want to optimize planting dates and variety selection? We're really thinking about the growing season, right? We're really thinking about how we can optimize the length of time that our cash crops have to access heat and sunlight and water, of course, to photosynthesize, right? So if we think about that framing with cover crops, right, we know that there are a number of opportunities that, again, you may already be working on, researching or doing on your own operations. And there's many ways that people can do this with cover crops, right? But what I want to focus on today is this third option and this particular project that my team worked on, right? So we know that people are interseeding or overseeding, during vegetative growth stages of corn in particular, or closer to harvest. We know that people are planting green, growing cover crops, planting cash crops into standing cover crops, right? Terminating them later. But this last point about, if you could plant earlier, what's the opportunity that you might have, and what are some of those trade-offs that might occur with shorter season cash crops? And so, again, the paper that I shared with you was something that a postdoc who worked with me, Nalobna Chatterjee, she's now actually a scientist with SIBO Technologies, doing some more modeling work. But what we did here was to work with some data that actually Roger Elmore and his team, who was a corn agronomist at Iowa State and also at the University of Nebraska, that Roger Elmore and his team had initiated prior to my being at UNL. But I thought it was a really interesting data set that we might want to work with. And what they did was to grow corn at 3 different planting dates with several different comparative relative maturity corn hybrids, and to see how those yields compared. And the whole idea with this was that if you had a shorter season corn variety that was planted earlier, of course, that could get harvested earlier, and that would give you more time to plant your cover crop. It's pretty intuitive. But what we did was to work with that data to test a model to see if we ran a bunch of different planting dates and actually some termination dates too, how much more opportunity would that give us to have more growth of cover crops. And so actually in my presentation today, since I wanted to try to keep this just to a shorter presentation, I'm going to focus just on the cover crop side of it. So I have, these 2 questions here. How much difference does that shift make on your corn yield. So I'm not going to, I have some slides if anybody's curious about that. You can see it in the paper as well. I'll refer to it briefly. But really what I want to talk about is the second question of how much additional cover crop growth can you get with earlier or later termination. We really just focused on cereal rye. So essentially here's what they did in the field and then what we replicated with the simulation model. So if you imagine a longer season or full season variety, which is really most typical where I am in Nebraska and my experience in central Iowa also, it's, you'd plant your corn not probably later than mid-May, and you'd expect to have a crop that you can harvest by mid-October or later. So we obviously know that doesn't leave a lot of time for cover crops. So we're talking about establishing it later in the fall in this scenario. And then, but if you had another 10, 15 days from a shorter or medium season variety, that could make a difference, of course, for having the opportunity to plant the cover crop. And then how much growth might you get by the spring? And then the third consideration that they had that was represented was even shorter season varieties that could allow for, mid to early September planting. And then what's not represented here is that they did also in this field experiment plant corn in April, May, and June to look at yields. So again, what we did with all of that data, we used it to test the simulation model. The name of the tool, some of you might be familiar with it, Sotiris Archon Tools at Iowa State is where I learned to work with this tool. We did some work during my PhD with it as well. The Agricultural Production System Simulator, it was developed in Australia. It's been really utilized widely around the world for several decades. It has a number of different elements. This is like one of these obligatory model slides that folks like to show, but it has, different elements, different equations that represent crop growth processes, soil dynamics. Again, this is my representation of it. So we use that field information to try to ensure that we have good estimates of corn yields and cover crop biomass. So of course, all models are wrong and some are useful. I think, you can take what I'll share next as, I think good, reasonable estimates. I hope you'll see that they, will represent maybe some things that you've seen in the field as well. There's a lot of people experienced here with cover crops, but to try to, again, understand different planting timing and what are the opportunities with extending that growing season window for cover crops. And so I'll explain, carefully what we're showing in this graph, but I want to just say too, that in the interest of time, I'm going to focus on cover crop biomass. What I will share about corn yields is that we didn't see yield decreases in the modeling and what they found in the field until their June planting window. So they found pretty similar yields in April and May. And they did see some yield penalty associated with shorter season varieties, as you might expect, but they found a lot of the medium and longer season varieties actually had similar yields. And so that was especially when you planted them during the April planting. So I think that is really interesting that there could be more of these growing windows in the fall than maybe we are considering. And so just with those brief comments about yield, what I want to show you here is that you're looking at a graph of our scenarios here of kind of planting every single day of a cover crop between mid-September. We actually started, I guess, early September and through November. So the idea is, how much biomass can we achieve if we're planting earlier, knowing that we're pairing on the other side of that kind of optimal spring planting paired with the variety length, the maturity length of your corn season, how much more time does that open up in the fall? So you're looking at predicted biomass values for all those planting windows between mid-September and the end of October. And what we did here was just assume a kind of conservative or average termination date of mid-April. And so I know I'm showing you in kilograms per hectare, and so it's not quite 1-to-1 when you're thinking about pounds per acre. But what I want to start with and also just explain too is that we separated all of the predictions based on the type of season that we had, because obviously many of you will know too that the amount of biomass you might get from one year to another, even with the exact same planting dates, is going to widely vary. So we grouped the seasons based on whether they were above average for temperature or moisture. So those are the four categories that you see here. And so this is based around the South Central Nebraska planting timing and climate. And Obviously, we can see that if you have warm and wet, that's going to vary greatly from if you have cool and dry conditions. So if we just start at the high end, what you're looking at here, so if we planted by mid-September, terminated by mid-April, you're looking at about 2,700 kilograms per hectare, about 2,500 pounds per acre. So it's pretty good for our part of the world, and kind of generally include us in that window. But that if you waited until late October to plant, you're looking at about a tenth of that, or about 300 kilograms per hectare. So a tenfold difference in planting date from mid-September to end of October, which again might be pretty obvious if you have experience with cover crops. But I thought it was really valuable in this project that we were able to quantify that tenfold difference, right? And the other thing that I think was interesting in this concept is that we can talk about what the model predicts the gain to be every day, right? So when you average this out by the number of the days that we looked at for planting dates, we're coming up with a number of every extra day, you're getting 55 pounds more per acre of biomass. I have my nice bright sun there in the middle to represent like that extra gain every day of sunlight that you're getting really does have a great benefit in the fall. And then what I'm showing you next is when we simulated different termination timing in the spring, because I'm hearing about lots of farmers too, and maybe again, you're doing these experiments yourself with planting green or different termination timing in the spring. So here we thought about kind of a conservative planting window in mid-October with varied termination dates in April. So you're looking at, again, planting mid-October, terminating every day in April. And so again, there's a big difference between terminating on April 1st versus April 30th, right? So if we start April 1, you have under 400 kilograms per hectare, but if you delayed until the end of the month, then you would have actually 4 times more biomass than if you terminated again the beginning of the month. And so, if we're thinking about the standard recommendation of 10 to 14 days post cover crop termination before you plant corn, I know it's not what everyone is doing, and lots of people are experimenting with planting green. This still, April 30th, provides 2 weeks before mid-May, which in our simulations and in their field experiments didn't show a difference in yield, which is pretty well my understanding of kind of the first to second week of May of not seeing differences, right? So the other thing that I want to point out, again, as you're seeing in these figures, is that we saw big differences depending on the weather. And so generally speaking, you can see kind of on average in the middle is that you need kind of average moisture or average temperature to get average growth of the cover crop. And that trend held true for both the spring and fall scenarios that we considered. So of course, we see those warm and wet years had the highest biomass, the cool and dry years had the lowest. So we see the difference between those highs and lows of about 4 times. So I just like to think about that as like, if you hear your neighbor saying, cover crops don't work, it could have been a bad season. And so there's like a fourfold, we're quantifying this 4 times difference between a great season and a bad season with the same planting and termination dates. And then another interesting thing is that we found that the average gain in waiting 1 day over the spring interval was about 30 pounds per acre, which is really interesting too when we think about the fall versus the spring, that what the model is telling us. And I think that is potentially similar to what my experience has been in the field. I'm curious if that is others' experience, that the heat units in the fall are actually more critical for optimizing biomass. Maybe that's not every season, but when we look at this on average, we see these differences. But still, once again, when you give the cover crop more growing season, it will grow. Imagine that. And again, the growing season unit may be worth more in the fall than in the spring in general. And so just kind of wrapping up this portion, I wanted to share one more example from a recent trial that we're doing in Lincoln about the opportunities of optimizing the cover crop growing season. But just to wrap up about our simulations, we see that the difference in the fall planting between mid-September to the end of the month is 10 times the amount of biomass, 4 times the amount of biomass if you're waiting to terminate from the beginning of April to the end of April. The moisture and temperature differences in a good versus a not as good season can be 4 times greater if you're considering the same planting windows. And then those last 2 points are related to yield, which again, I'm not focusing on here, but We didn't see, again, yield penalty associated with April and mid-May planting timing. Some yield penalty associated with shifting some of the comparative relative maturity hybrids, as you might imagine, but less so earlier. Okay. I want to, again, briefly share an example of what we found in what was probably a very good year this past year of what happens with a legume growth. So when we think about, optimizing all those considerations for cover crop management, what we can learn from managing a cover crop like a cash crop. So the results that I'm going to share here come from the first year of data from a field experiment that's primarily been managed by a PhD graduate student working with me, Tawana Almeida. This is a part of the Precision Sustainable Agriculture Project, which is funded by USDA NIFA. And actually this experiment is being replicated at 15 different locations in the US. And let me just tell you a little bit more about the experiment. It is a kind of somewhat classic agronomy experiment. So we're looking at corn grown with 6 different nitrogen rates and 3 cover crop treatments. I'm showing you the treatments here. So we have a cereal rye, we have a hairy vetch, and we have a mix. I'm showing you those seeding rates here. And so we're planting the cover crops following oats, right? So I know that that is different than what I've been showing you here. It's not only a corn soybean rotation, but the goal of this experiment is to really understand if and how cover crops can change optimal nitrogen rates. And we really want to look at the legume in particular and make sure we have enough growing season to get the legume well established in the fall. And so I'm really proud to say that in 2020 and 2021, we grew perhaps like the most perfect cover crop that we're ever going to grow. And I know that this could be a little bit anomalous, but the point is to say, what's the opportunity that we have when we let the legume grow longer? And so in particular with the mix and the cereal rye. So cereal rye did dominate our mix, but I'm showing you a picture of our research technician here, Tom Galusha, in this a few days before we terminated, a very lush stand of the cereal rye, very full, not very tall. So it's about up to his knees. And so we had full stands, excellent fall growth in 2020. We terminated perhaps at the perfect time at the end of April. And when I say perfect time is that the rye didn't start to grow really rapidly, so that would have increased in carbon content. And so we have the carbon to nitrogen ratios of all of this residue, and the 3 different treatments never reached the point where there was a mobilization occurring. So they never reached a C to N ratio above 25, which is a really encouraging result. And so I'm showing you what the biomass numbers were that we got here, which I know is a very high number for our part of the world. And we're thinking about winter cover crops. We did have over 5,000 pounds per acre of rye in the mix, and a little under 2,000 pounds per acre of hairy vetch. And again, those carbon to nitrogen ratios never reaching the point understood to initiate a mobilization. And so within this experiment, we have litter bags, which is a fun science thing to do, where we fill litter bags at cover crop termination. We leave them in the field to see how much decomposes, bring them back at these strategic points throughout the growing season, weigh them, dry them, and then look at the carbon and nitrogen that is remaining. And so what we calculate actually is that there was significant nitrogen released over the growing season. So you can see that your x-axis here is the week after termination, and then the cumulative nitrogen release. So I'm showing you here, and I know I've been back and forth between pounds and kilograms per hectare, but you can see that there was between 70 and 80 kilograms per hectare nitrogen in all 3 of these treatments, which is really significant when we let the cover crops grow. And there's several interesting things I also want to point out, draw your attention to here in terms of yields. And this is kind of the end of most of the things that I'd like to share, of a few kind of parting shots as well. But I want to show you here the yields in the corn, the 160 pounds of nitrogen treatment. So again, we have these different nitrogen rates. And so we did see at this nitrogen rate that the hairy vetch had the greatest yield. We did not see any significant differences with the cereal rye and the mix between the control. So that's kind of treatments 1, 2, and 4 that I'm showing you here. And then when you also look at Interestingly, this is a neat thing we can do in this nitrogen rate trial. If you compare what the yields were when you go down a nitrogen rate, so the hairy vetch grown with 80 pounds of nitrogen compared to the control at 160 pounds, there might be numeric differences, but not statistical differences there. And then if you went up one N rate, if you compare the 160 pounds of N in hairy vetch to 240 pounds of N in the control, again, no statistical differences there. And so from my back of the envelope calculations here, when you think about the price that we paid for the legume seed and what 80 pounds of nitrogen costs, and then our seeding rates, the legume does come out just a little bit better. I know that prices are all over the place right now, but it comes out just a little bit better. And again, I know that this is not representing a small shift, but is meant to illustrate the nitrogen contribution that is possible when you're giving the legume more opportunity to grow. And I will also say that we had outstanding weed suppression from that much biomass with the rye and the mix. And, the rye seed costs are about $15 an acre. So it could be really comparable to herbicide costs. Again, I know herbicide costs are increasing, as are many things, but it's just really promising results from this first year to show what a cover crop could do for offsetting potentially some of the input costs associated with fertilizer, herbicides. And again, when we give the plant more time to photosynthesize, right? And I know that this is, maybe more complicated management, but it's really a systems approach, right? And we know that for something like this to work, we need to be thoughtful about all aspects of what you grow throughout the year to make your cover crop really work for your goals. And then just to conclude, I want to show you a few quotes from Iowa farmers from a project that I worked on while I was a grad student at Iowa State. We held focus groups with farmers who were utilizing cover crops in Iowa. This is back in 2014. So it's been several years now, but they shared some really great ideas with us that relate, I think, really nicely to this idea of managing cash crops like cover crops. And so they describe cover crop management as a system that requires attention to detail on many levels. And again, probably pretty intuitive, similar to, how we think about our cash crops. And they express even that, the research that's been done by myself and others, right, doesn't always change all of these elements of management that are necessary to make cover crops work. And so finally, my kind of concluding thoughts are, I do think that when we think about this framing of cover crops like cash crops, it encourages us to think about how we can use more of the growing season to help the cover crops achieve the goals that we really want to have for them. I think there are ways that we can do this that have a more optimal benefit with limited yield impacts. And what I tell students, I'm sure many of you understand this as well too, that I think the number one thing is just determining your goals for the cover crop, right? And that it might really be that giving the cover crop a little bit more growing season is worth maybe a few bushels if that's giving you more weed control, nitrogen, forage, et cetera. It really starts with your goal and then how you optimize management in a systems way. So that's what I wanted to share. I'm happy to go back and visit any of my slides, but here are my CCA announcements that if you watched the webinar, you can email Liz to get credit for it. So I also have an announcement about the next presentation if you want me to move on to that next, or maybe I'll leave this here while we answer questions.
Yeah, I think we can get to a couple questions and then move on. We've gotten a couple, but I'm sure more will come in. So I get to, as a moderator, I'd get to ask the first one. So just make sure I
Sure.
understand it correct. On that site where you saw the yield benefit with the hairy vetch, that was where you had almost or about 1,700 pounds
Yes.
per acre of biomass. Okay.
Yes.
Yeah.
Yes.
Yeah.
Big.
Okay. Big. Yeah.
For a legume for us.
I know. I'm like, hey, that's big. Yeah.
Well,
okay.
It's funny because, we have all these collaborators at other sites and they'll make comments and say, oh, well, if you have less than 1,000 pounds, it's not worth it. And I think, that's a great year for us some years.
Yeah.
And there still is benefit, but anyway.
Yeah, no, that's what, I'm just thinking back to how little I've seen in some of our fields in Iowa. So, okay. First question is, and this, maybe even somebody else weigh in, but what type of termination is best suited for central Iowa latitude? Is there a good mechanical versus chemical termination technique?
I mean, I welcome anyone else who wants to add to this as well. Most of the experience and the things that I see here are chemical termination, waiting for the right optimal weather conditions. I would say this year too, making sure you're getting the product that you want to have, because that could be a challenge. It could even be a challenge for us at our experiments. And my limited understanding, and I don't have field experience with roller crimping, is just you have to let that cover crop grow to a much more mature growth stage. It's going to take longer in the growing season to have success with mechanical termination. So I welcome if anyone else wants to add in the chat or unmute themselves to share.
Okay, next one is, and we can see if anybody else chimes in on that. I'll make sure everybody gets any thoughts. So thoughts on why the hairy vetch treatment yielded more but didn't show greater nitrogen release over other treatments?
Yes, that is a really good question. If that is like the rotation effect, if that is technically, the same amount of nitrogen that the rye had, which is what our data shows, or perhaps there's something more happening below ground. That's a question, and one that I don't have a great answer for yet, but those are a few of our thoughts.
Yeah, as a non-soil scientist or non-agronomist, I was wondering how much, maybe the below ground was playing into some of that.
Right. It would have to be, and that's not something that we measured. So
yeah, above ground biomass is tough enough. Below ground roots are yes.
Right.
Okay. Somebody did ask here, he may have missed at the very beginning, but did you indicate what varieties of rye you used as part of your studies?
So I am not 100% sure on the field experiment prior to. We may have it in the paper. I'd have to double check. And I see actually Margaret Smith sent a question to me.
Okay.
I should have said that explicitly. I think I had on a slide that yes, the simulations that we did were just representing cereal rye. And so the way the model's set up, it's not going to give you an opportunity maybe to tweak all of the things that you might find. And I mean, it's kind of about just like the basic physiology of the plant. So I don't know that we could fine tune it enough for the variety, but I am actually not sure the variety that they use. I'd have to double check from that field experiment.
Okay, here, what might you expect to see if you were planting cover crop in the V4 to V5 stage in 30-inch row corn?
Yeah, biomass production. Huh. I don't have a great answer for that. I'm gonna be honest.
Okay, great. That's okay.
My experience with interseeding is it's also very season dependent. Yeah. And just like any kind of overseeding is that it's, or airplane or other aerial seeding, that it's like if you have a timely rain. So I bet someone else has a good answer to that, but it would be really interesting to look at what the data shows in terms of, in a similar way of what we did with the model, just with the intercropping, because it's obviously not the same as what we're representing here, which is just a clear field, all the sunlight. So I don't have a good answer for that.
Maybe
I bet somebody else might.
Okay. Maybe we can go to the next slide so we can just put in a plug here for the next webinar in case some folks have to get off. I don't even know what's coming. All right. All right there. We have Dr. Angie Carter talking about
another Iowa State alum.
That's right, on women's farm organizations. So protecting status quo or transforming agriculture. So that'll be a great one. Good discussion, I think. And I had a thought I was going to ask you there, Andrea, and it slipped out of my mind. So we'll go back to the questions.
Sure.
Because I know what I was thinking is that to me, that interseeding, the models are kind of challenged sometimes with even that the cover crop afterwards. But boy, then trying to be able to in the future be able to model, maybe a cover crop below that corn crop
Right.
might be a real challenge in understanding light penetration and that kind of thing.
Right. I don't know that would be the best Yes, it would be more complicated than what we have represented here, which is more straightforward.
Yep. Here we go. We got one. We've been told for years that an early planting date is essential for maximizing corn yields, generally in conventional no cover crop systems. I think you said that your study saw no penalty for delaying corn planting to June. Would you credit this to variety selection, the use of cover crops, or both?
Right. So make sure that I'm clear about it. And let me see actually if I've got a slide or two here. So they did see, so this is essentially a representation of what they did in the field, which was to have about mid-April or toward late April, mid-May, and early June. Mm-hmm. And so you can see pretty clearly that there was a decline once planting into June, but that really, if you looked at the same comparative relative maturity, 115 day planted in April or May, that there was not differences. So if I spoke quickly about that, I apologize. And I really do appreciate that question, because that is the, common thinking. And I have colleagues who say the same of soybeans, that the sooner you plant, and certainly the research shows that. I mean, I just think that the idea here that I'm encouraging us to think about is, that the last point that I ended on, that is the cover crop benefit worth giving a little bit of extra growing season to, and trying to figure out, that some people can make it work with planting green. Other people are figuring out interseeding or, potentially earlier harvest. I don't hear about a lot of people kind of utilizing this strategy yet. I think what was novel about what we try to do here is just to show what the potential would be. So yes, you hear that. And I see that as, proven, but I guess I'm just asking, could we think about giving the cover crop a little bit more growing season too, if you want to try to, achieve greater benefit?
And maybe folks could think about, maybe it's not killing all of their cover crop at the same time, but they think about, what fields might be the latest planted, or could we delay planting and do that? And maybe you rotate that from year to year to try to get more growth, I guess. Okay. There are a few more questions. I'm talking too much. Okay. Their next one was, did you plan to collect any soil health measurements on any of these sites? So
the experiment that I guess the answer is kind of no. the nitrogen rate study, and I see actually Margaret had a couple quick questions about it too. We terminated those with herbicides, with glyphosate. The vetch took a little while to die, but it did. We're a little concerned about that. But the primary emphasis is really on understanding some of the, what's the yield impact with the different rates and the cover crops. Does do the different cover crops shift economically optimal nitrogen rates? And so again, we have a whole team of people. You could have somebody back from the team, Hannah Poffenbarger, who's also an Iowa State alum, is leading that effort for the Precision Sustainable Ag Project. And I think we'll find some interesting things. I'm really interested in what we'll see with the legume, but soil health is not really, at least for this project, an emphasis of it. It's emphasis of some of the other things I'm working on, but not this one in particular.
There was a question, and I think I just relay it. In your studies, the cover crop biomass was left on the surface. It was not incorporated.
No. Okay. And in the model, we wouldn't have we could kind of try to replicate some incorporation, but we don't. Just assume that it's decomposing based on temperature and moisture.
Okay. One, they indicated they've recently heard about relay cropping where there's no termination and you harvest the cover crop. Thoughts on relay cropping in relationship to your findings on the length of cover crop in the ground?
I think it's a great idea. I look at the landscape in the month of May and June, and I think, well, that's really in our region when we get the most rainfall, right? So I think if you can have more plant plants transpiring at that time, it has a huge benefit. So the research shows for water quality. And so I think if people, I know it's complicated, but I think it's really positive if people can figure out how to make it work and have more plants growing in May and June, bigger plants, which really is, cool season crops. So go for it. Find the innovators and learn.
Okay, great. There's one. What kind of differences might you expect if farmers used winter wheat or triticale instead of rye?
Yeah, I don't have a huge amount of experience with either as cover crops. We're actually starting some variety trials with cover crops around Nebraska. That might be of interest to folks in Iowa at some point in the future. But I think that people do have a lot of success with them. Again, I don't have a lot of experience, but I think that you might expect comparable results by, numerically, depending on the season. But I think that, depending on seed costs, and your system, that either could be good options instead of cereal rye.
Okay, great. Another one, and maybe this is part of the broader research, the CAP that you're on. Are you planning on turning this research into a cost benefit calculator to help people decide what to do based on crop and soil?
That it could be. I don't know if that is a part of the plan, but I think, the seeing how the economically optimal rate shifts and doing a little bit better than my back of the envelope calculation that I described. I think that could be a part of the plan, but starting with these phases first. So I think that's a great suggestion. And one I think people are really interested in right now, given the price of inputs. So that's a good question and suggestion.
There's one here. Are we running up against the limitations of cover crops in the corn soybean rotation? And is there any hope for breeding improvements to corn and soybeans so that they mature faster?
I think that does have potential. I'm not really familiar with how advanced that is, but what I can say from the field data that we worked with for the modeling is that, again, they didn't always see huge differences. There was almost sometimes the 102-day variety was yielding the same as 115-day. And so I think that does have a lot of potential. And I would say, I do think that we run into the limits of what is possible with a cover crop and a corn soybean rotation. Absolutely. I mean, if I had to summarize in one sentence, my 4-year dissertation of cereal rye and a corn soybean rotation at Iowa State was exactly that there are benefits. Absolutely. But there are also limitations too, that are just real, that are constrained by the cropping system and the climate. So I do think that there's potential if you can harvest earlier, if people are willing to do that. I know people don't always want to do that, even if the crop can be harvested. So I recognize it's a challenge, just encouraging us to think about what's the potential for the growing season.
Great. I think that we got to most of the questions, or essentially all the questions. I don't know if you need to come directly to you.
Yeah, so Margaret asked one that I think I answered, and Doug Johnson asked, are the yield date for corn following corn with and without a cover crop? I don't know if he is still on and wants to say more, but I'm not sure about that question.
Okay.
That was the only other one.
Okay. Yeah, I'm not sure he is. Was that corn following corn or corn following soybeans?
Are the yield date for corn following corn with and without cover crop?
Oh, yeah.
I'm still not sure if I understand.
Okay. I think we can move on.
Sure. So I think that was all the questions that I saw come in the chat. I see Margaret commented too that the hairy vetch could be the root biomass.
Yeah.
I think that's very likely, but not something that we measured. So
you better get those grad students on collecting roots. No,
it's a really complicated experiment.
Yes,
a lot of work already. So maybe we'll see how much undergrad support we have this summer.
Yeah. Adding in roots, it's like it takes it up orders of magnitude.
Right.
I think.
Right.
Yeah. So, okay, Andrea, thank you so much for the webinar today. It's great to see you, and thank you for sharing your information with the Iowa Learning Farms webinar, and hopefully we'll be able to get you on sometime again.
Yeah, great. Well, thank you for the invitation again. Nice to visit, Matt, and see everyone. Appreciate the good questions and engagement. So thanks.
All right. Take care.
Bye.